Reconnecting. Now. I'm back. I'm back. People, I'm back. Can you hear me? I'm not gone. Hello? Don't leave. Please don't leave. We're back, folks. Okay, the internet is a little shoddy though. Internet Chan is having some of those code 5s. Yeah, Twitch. Our code 5s have transferred into the Twitch backend. Ooh, my internet is very shoddy. I'm sorry, everybody. I'm probably robot-y as hell. Oh, it's working, though. It's working hard. You know what we gotta do now? We gotta work on functions. Okay. Ooh, the stream went fully down. 0 viewers. No! I am having fun implementing. Eternal Wild Fox says, "What do you? That's really good. What are you implementing? If you can still hear me, my internet still works. I can still like look at myself. Oh shit! I have transcoding available. That's fucking dope. I can watch in 360p. Hey, my internet's back. We're back. Please, please say we're back. Hopefully we're back. Nexovex is 160p, gang. Yeah. Lamau. Eternal Wild Fox, implementing parse rules for the Pratt. Nice, that does sound fun. Rohan says, all good, we're back. Hey, we're back, we did it. We're back up, yeah, my bitrate is back up to normal. Just above. Alrighty, we're good. We only had 1,000 dropped frames in a row. So, you know, nothing horrible happened. Oh, Christ. So, node type function. Handle functions with empty body. That's definitely something to do. We have a body expression and last expression. While body expression, type check this expression. We can't do null because we do a bunch of dereferencing. So we're just going to have to say expr return type. We'll put that there, and then we'll just free it. Wonderful. What's the problem? Undefined reference to expression return type. Do we call it? Wait, that says type check expression. What says expression return type? Oh, down here. So type check the last expression twice? We don't have to do that. We can just say last expression type. We'll say it equals null. Last expression type is equal to the expression return type every time. So then when we are done, while body expression, we would like to say free expression return type, probably after all this stuff. Rohan says nothing compared to those horrible code 5s, Kappa. Lamau. Nexovex says, how long have you been failing to program? About 6 years for me. Either 6 months or 10 years, depending on how you look at it. Because I learned like very basic C++ when I was like 11 or 12 or 13. I don't even remember. Probably 11 or 12. And I learned like, oh, an if statement needs a 1 in it, and then you can go. And like, oh, if it's a variable and it's an integer and it equals 1, I get. So I learned like very basic control flow and math and expressions. But I remember when I was 12, I tried to make like a recursive descent parser, and I was like, yeah, I got this, and then I did not got this. I failed and gave up. And then I never touched code until like 8 months ago. Last expression. I don't need to type check the last expression. We already have the last type. Right? We get the last type here. Perfect, perfect. So then with this, I guess we could just use expression return type itself as the last one. I realize now. So we should say basically and that's still fine and dandy. So compare return type of function. So return type of function, we are in a function. So the return type is the children next child of the function itself. That makes sense. If we look at parser.h, it supports that. Where if we go look at a function, children next child will be return type. And that's the return type symbol that's been parsed, not the return type value in the environment. So we say do the thing. So this is so wrong. How did this ever work? So we need to compare the return type of the function to the return type of the last expression in body. The return type of the function is not this, but can we do like a type symbol compare? Because what's our expected and what's our actual? So our actual is expression return type. So let's just do this, right? And we'll say print out that return type. Please. I'd like to see what it is. Function return type of last expression in body. That's a little complicated, but it's a testing debug message. It doesn't matter. It's an integer. Is that true? I think that's true. Oh, but more importantly, it's the integer value. So we are going to have to do what we did before with the getting the ID and return type and everything. But the actual return type is going to equal something else. So we're going to say node pointer return type. We'll call it function return type to not confuse ourselves with result type. So the function return type is this, and this is the symbol. So what we're going to do is create a new node instead of using a pointer that's existing. And we're going to copy from this node into our function return type. Paug. So then our function return type we're going to need a func return type. We'll just do function iterator. And this will get us to whoops. There we go. So while function return type iterator does not equal symbol. Is this how I should do it? This is a function. It does not equal symbol. Let's just go to the very child. Right? So we'll say while children. I think that's makes more sense. So then we would like to use this function return type iterator to actually get our function, like the actual thing it returns, right? Also result type is going to be equal to a node type function, right? I'm pretty sure that's that. So we need to compare this return type. Let's store it in result. And then last type is going to be our expression return type. There we go. We're type checking the return type of a function now. So now in point, when we return 0, it returns and checks, hey, that's an integer. Perfect. If this wasn't an integer, like if it was a pointer to an integer, says, hey, mismatched types. Return type of last expression in function does not match function return type. Look at that baller error message, everybody. That is dope. Oh, once we get some spans in here, this is going to be like tell you which line to go to, exactly where. Oh, this is becoming much better. So now let's look at code.s. Oh, let's try function calls. Are they still broken? That's not as broken. I think we fixed something in the while we were doing that, chat. Oh, we did not. we definitely most certainly did not. That's a problem. We do not want that much stack space. That's definitely going to stack overflow, chat. That's definitely going to stack overflow. That's definitely going to... It's going to generate a large executable, is what's going to happen. We've got some issues in code gen now, but hey... See, this is what it should be. How does this work? Next of X is not if the whole heap is a stack. Oh, that's a really interesting idea. We could allocate memory and then set the stack pointer within that allocated memory on the heap. Oh, that's scary. That's a little scary. So here's what our numbers are supposed to be. But when we have a function call, some things go wrong, as you can see. God damn it. What happened? I like how every once in a while you see a regular number, like 16. God damn it. I don't even know how that works. God damn it. So why does a function call ruin everything? What happens? We say iterator is equal to a pointer in the AST. See, then we probably free iterator. Yeah, and we even say iterator equals iterator next child. No, we never free iterator, so we're good. We don't have to worry about that. So if we don't do this random node free, did that work? Did this node free? Was that the issue? Recompile. That node free was the issue. This is wrong. Done. Well, that was easy, wasn't it? Don't we still free result? We still free result. So it should still be like result equals null and stuff. I don't know. Either way, we fixed it, chat, with no debugger. Look at us. Ooh, hey, did we get a, what do we see? What do we have in the Discord? Something happened. We had a code review. I added parser rules into my parser. Ooh. This is such weird syntax highlighting. Just so you know, Eternal Wild Fox, if you put 3 backticks, anything in between these is syntax highlighted like a code. That's how this type of stuff is done. And if you put the language after the first 3 backticks, like if you're writing in C or C++, it'll do automatic syntax highlighting for you. Just so you know. Hopefully that helps. In any case, what do we got? Parser rules. We have precedence with term factor. We have a dictionary of token type to parse rules. So when you encounter a plus, you say new parse rule binary precedence term. I'm not sure what a rule is at this point, but it's interesting. Expression handler is private void expression is running while is running. Get a token from the lexer. Get a parser rule. And then switch on the parser rule to determine which function to call. I see. So parser rules are kind of like AST types. in a way. Yeah, it's like a node type is what a parse rule is. That's very cool. Thank you for sharing, Eternal Wild Fox. It's looking pretty good. It's a little odd to, like you can't do string cases most of the time, so that's an interesting thing. I'm not sure which language this is in that allows for that. This is probably C#, which allows for that. But yeah, if that's allowed in your language, then this is looking pretty good. Yeah, this is definitely C#. Throw no exception. Eternal Wild Fox says, this is C#. Yes. Nice. Nexovex says, it's true, there is no stack and heap if you're mentally deranged enough, Lamau. There's no allocation either, just memory protection. That's true. You start to understand that when you write an OS, and you're like, oh, I have access to all the RAM. I could just overwrite the BIOS. It's amazing. Well, I think that's us done with. So you'd think that result children are just allocated nodes here. So you'd think that node free would be fine, but it's not. So we should just say, I mean, really, we just need to do garbage collection when we run out of allocation. That's really all we got to do. In any case, our code now generates properly. And let's figure out what this should return. What do we have? We have bar called on numputter, which should set the putter that we're given. It should dereference it and assign 69 to the memory that the pointer points to. So if numputter points to number and we call bar, then this should return 69, even though number is set to 0. It should be set to 69 through this pointer in this function. Nexovex says, I don't actually fully understand that, but there's OS level API that just lets you YOLO and play with memory any way you want. Yeah. Nexovex says, I'm not sure I want to write an OS. You are correct for thinking that. It's a large task that takes an incredible amount of work, especially from one person. Rohan says, garbage, here, collect me, I'm garbage. with the trash emote, Lamau. Here, collect me, I'm garbage. Now that's a t-shirt. So this looks pretty simple. We have a function called a foo, which is here. We have bar, the definition, right? We have a function called a foo, then we have a function. That's incorrect. Why do we say function here all the time? It just says function for no reason. I wonder if we're printing that out on the global level. I think we can fix that. Whoops. Function. Yep. Just do that. We will now no longer randomly print function into our helper comments. That helps a lot. Helps a lot. Okay. So now we have boo, boo and far. We have foo and bar. We have a function called a foo with no arguments. We have a variable reassignment of a global variable, which is number. So we move 0 into number. So if we take a look at our code, you can see that moving 0 into number happens here. We have a variable reassignment here, because all the declarations are global declarations. They don't actually get executed, so there's no code generated for them. So we have a variable reassignment of numputter. Nexovex says, you code too fast. Lamau. Let me know if there's anything I can slow down on, and I can spend some time and explain it and take the time to actually go through what's happening. But you're right, I do code too fast. I need to work on my presentation skills. Rohan says it's the coffee. I'm actually coffee-less today. I'm coffee and cocaine-less today. No cocainum, no coffee. No stimulants of any kind. I'm just excited. Chat, when I code this fast, I'm just excited. I'm ready. I'm excited. Oh, I'm so ridiculous. So we load the effective address, LEA, of number, our global variable defined right here, 8 bytes of space in the data section of our executable. And we load the effective address locally from our instruction pointer. So our instruction pointer points to like here in the executable, and somewhere else in the executable is this number. So we say just load the offset from RIP into racks in this special way. That way we don't have to actually care that number stays in the same spot. It can just stay at the same offset from this instruction and everything will be fine. So if the data section stays behind the text section as it's outlined, then you'll just get a negative offset back to number, rather than dealing with all these absolute memory addresses, which the linker should really deal with if it wants to. So we are generating position independent code, PIC. Nexovex says, you don't need to slow down, but I'm just slower than you. I'm pretty sure I'm slower than me. Because I don't understand everything I'm doing unless I slow down either. But no, I really don't mind slowing down. It's a positive thing. Because it's, I tend to rush through things and get them done without thinking like, oh, there was actually a really cool thing we could have talked about there, or stuff like that. So I do not mind questions, slow down, saying, you're going too fast. I'll definitely slow down. Because it's easy for me to just like, go, 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 go. Because that's how I get things done. I'm just so stubborn that I'm like, I'm gonna get this done. And when I get this done, I'm gonna get the next thing done. And I just keep that mindset. But it's not great for presentation. I gotta be a little more mindful. But yeah, so this variable reassignment here, I wish the highlight, can I highlight line? I don't think I can. Highlight region? I need to write those. Or I think Pro has an Emacs package for that. What's it called? Is it denote? No, that's his note taking. Proton. Is it called Proton? I'm gonna do it. Package install. Is it Proton? It's not Proton. It's It's pro something. Pronto, Prodigy, Proganth, Promise, Prompts. Oh, it's probably not in. It's probably in the non-GNU ELPA, which I don't have on this Emacs. Ah. Whatever. Rohan says, and then we land at code 5 and I hear you sing, Deja vu, I have seen this code before. Lamau. Okay, so with this address of, we have the address in racks, and then we move from racks. So we basically move the address into numputter, which makes sense. We have our address in racks and store that in our putter. Then we do a function called the bar, which means that we need to do a variable access on numputter. So racks now has numputter result, and then we can just push racks and call bar. So our one parameter, our putter, has been pushed onto the stack, and then we've called. So now we will jump up to bar, excuse me. We'll do a bunch of function starting business, and then there's a variable reassignment of 69 into the dereferenced variable putter. So we move the actual stack space. Rohan says, at some point we have to make code 5 rickroll you, lol. Nexovex says, oh, where do those pointers go? I just want to tell you what my memory address is. We could write a better one. It's a good start, though. We basically, off of the stack, from this base pointer here, we pushed this, and before this, the call instruction pushed 8 bytes for the return address. So 16 bytes above the base pointer, which is the stack pointer at the beginning of the function call, we find our first variable, our putter. So we move the address into R10. And then we move racks, remember 69 is in racks, into R10 dereference. So R10 is used as a memory address, and it's calculated, and it's actually written to the RAM at that spot. Now, because this pointer pointed to number, that means that this dereference here should write to the number address, the number 69, and then we'll return 0 from the function and do our function exit stuff. So now all we have to do is test. Racks equals 0, but never put in number address. Where? Racks equals 0. We move 69 into racks for a value for the dereference. And then here, for the function call to bar, we say move racks into numputter. So yeah, racks has the address of, yeah, because this is this reassignment. So numputter has the address of number loaded into racks. Racks has the address of number in it, and that's loaded into numputter. I think it's fine. Let's try and run it. So we're going to write our little command, and it is going to be, let's see, we're going to use as GNU assembler. We're going to generate an object file from this code file, this assembly. That's not the only thing we need to do, because we can't run an object file, so then we're going to use the GNU linker, LD, and output an executable from this object file. And then we're going to run that executable. Crazy, right? Oop, guess what I just did? I deleted it all before I ran it. I hit Shift-Enter instead of Enter. So code.s, we want to link into an executable from code.o. Then we want to run code.exe. Hey, chat. Chat, shell command failed with code 69. Yes, this program returns 69. We did it. That was so difficult. So now we can do a function call with a pointer as a parameter and dereference that pointer parameter to actually write to an out-of-scope variable. Oh! Because number does not exist. We can't go here and say, oh, number is equal to 69. If we try to do that, our compiler says, hey, reassignment of undeclared variable, not allowed, dude. But using the pointer, we can later define an integer and have this function work on any integer defined at any point at any time in the language. Cool. That's so cool. You could also just say like number is equal to bar and return 69, but this is cool. Right? Rohan says, and then we go back to coding because we get an error. It's true, but we get to code in our language now. Haha. Right? Using a pointer to mutate a variable may be created, we'll say an integer variable that may be created at any time. Cool. I want multi-line comments to be more efficient, and I kind of want Doxygen support as well. But that's thinking way ahead. What we should do is do some git commit and some push. I have way too much little examples and stuff all over the place. This is awful. I really need to clean up my working tree. In any case, let's figure out what I can add. What happens in this case? Num is equal to bar of numputter. Number would be 0. We'll do it for you. Code 5. Ooh. Oh, we don't set the return type of function calls. Whoops. So, neg vorsa, 0. You are correct. It would be 0. Because bar is going to return 0. So this will happen. The side effect is number 69. And then the reassignment will have calculated the right side, which set number to 69, but it doesn't actually matter because this returns 0. So then the result register will contain 0, and we'll move the result register into number dereferenced, which means number will be 0. In any case, you helped us find a bug, so I appreciate you. Function call does not set return type. So what is the return type of a function call? It's the same as the return type of a function, is it not? It is. So we basically, in the type checker, not the code gen, function call. Yeah, we never set result type in here. That's definitely an issue. So result type should just be whatever the return type of a function is. So where do we have that? Do we actually set, we just set it to function, so we never actually did that, but we do it here. We're going to copy this. I don't think we need the type compare, so I'm going to copy this. And we're going to need this in function call, because function call needs to return the proper type. Function call, those should be next to each other. That doesn't really make sense to me, that these are completely separate. I'm a weirdo. We have function return type. Redefinition. Each switch case doesn't get its own. Okay. Whatever. So we're just going to say func return type. Sure. And effectively, wow, I'm really surprised you're able to use variables across switch cases. I see why they don't want you to do it. Because we could use function return type even though it's defined in a different switch case. That's a little scary. Anyways, func return type. See, it's so dangerous. There's no function now. Okay. So func return type means that, see, we don't want to do that. We want to get it into result. So func return type iterator basically says copy expression children next child. So this should be the return type symbol of the function. So func return type, we're going to set func return type to return type symbol of called function. Called function should be in value, right? So we're going to have value children next child. We're getting there. So now I would like to print node result. If I need to slow down and explain what I'm doing, let me know. I just realized I've just been coding. I haven't thought about what I'm saying, and I haven't given it one bit of thought. So let me think about this. We're in a function call, and to get the return type of the function call, well, it's just the return type of the function. So we have the function, actual like definition node, in value. That's where we look up from the function's environment our function that we've called and get our value. So value contains our function, which we use often. So using value here means we are getting our function return type here, a child of our node function. Okay, so when we have that, we copy that into this new node because we don't want to change the return type of the function, but we need to alter this return type symbol to a return type value. So instead of having like a string integer, it'll have an actual node that represents an integer. So it's going from like abstract to concrete effectively. And to do this, well, we've copied our type symbol, but now we actually need to find the symbol that we're going to resolve, which is the last child. So if we take a look here at our function, for example, you see that it's integer, but if it returns a pointer, then we would have like a pointer to an integer, like here. So we're going to go to the last child to skip past all the pointers and such, like that. And once we get to this last child, then we're going to use it as an ID to look up a type in our context for the function. Which, is this right? This doesn't seem right at all. Context to enter correct, like, at all? Do we need some link between function definition and function context? It's a good question. So we're just going to put a big to-do / fix me here and put these questions. Fixes everything, right? But in any case, we're going to need to look up the proper context to get the type from, because when the function was defined, we need to know which context it was defined within. It's like we need to know which context function was defined within to properly check that return type is valid or whatever. Because the return type may not be in the global context or the one we're in from the function call. So just for a concrete example, if we eventually, we're going to allow for type definitions. So if we had like type def, this isn't what it's going to look like, but if we had type def I as an integer, right? And then you try and use, create another function, because we're going to allow for nested functions, right? Which returns I. Well, we can't look up the symbol I in the global context when we call bar or bar, because then we're going to need this context here. Or I guess this function will never be allowed to be called outside of this context. This may not be an issue, interestingly enough. It's a very niche issue, for sure, because nested functions are not common to support, but we're going to. We still have none return type. So what do we print out for like result? Result, we get none, integer 0, int 8. And then what else do we have? We just print out result twice. Why would we do this? So I want to print out the func return type and say func return type. So the resolved function return type is integer. That's incorrect. We don't want a symbol. So what we're going to have to do is say, what if can I write into itself? Is this function work? Will it allow this? We still get none. So I'm going to go with that. May not have worked. So what is result? Result is none, integer 0. How does that make sense? What is the none? Where does this come from? Because the result should be like integer 0. Type not found integer. What? So how is the integer type not found? That's very confusing. Also, I've been streaming for so long. I gotta end soon. Okie dokie. Before we start wrapping up the stream, I do want to mention now, be sure to check out down below in the About section, and you will find a link to my YouTube, which has all of the previous broadcasts, and you can see how we wrote all of this code that got us into this terrible mess. Rohan says you streamed for 40 minutes. Kappa. It's been 2 hours 20, I swear. You're so funny, Rohan. But yeah, check out the YouTube. It has all the previous broadcasts, 6-hour videos on pointers, whatever you prefer. Go check it out there. There's the Discord. If you are not here already, it is a ton of fun. Eternal Wildfox is asking for some code review on his parser. Still need to figure out how to do the precedence though, but the start is there. Absolutely, you're absolutely correct. But yeah, we have a ton of fun. There's notifications every time I go live, so you'll never miss another stream, etc. I really recommend joining as long as you're ready to be a decent human being. Henderson also said goodbye. But yeah, along with that, there is the donate button in the About section, and I would greatly appreciate any and all donations that come in. Even if it's $1, you can leave a message and your name, and I will read it on stream. As long as it's appropriate, of course. First time chat from a new viewer, Arnow478 says, "Hi, how's it going, Arnow? What's going on?" That's an amazing emote. We got a kiwi pat from Arnow. Is that a premium emote? You coming in here and flexing on us? So function return type, I want to kind of do like that. Still not correct. Why is it none? I still don't get why it's none. If anybody understands this, I would love to know. Why is result none? Type not found integer. Arnow478 says, "Just that I love coding compilers and I searched for that on Twitch." Awesome. Well, here you are. We're in the middle of it. We're doing type checking of function calls, and we are realizing that we're screwing up the return type of them. So we're going to try and figure that out. The return type, we get integer first, but then we say type not found integer and none. See, this doesn't make sense to me. I'm not sure what's going on here. Type not found. See, we're getting this. So if we return this error, we say type is not found in environment integer. What environment are you looking in? Right? So let's printf. I mean, we'll just do like a parse print context on what we're doing. Parse context print, that's what it is. Context to enter. Exited abnormally with code 5. Okay. So is this null? What is this? We got that code 5 sneaking in again, by the way. So it's not null. Is this null? It is. Okay. So we're just gonna do like context. I don't know why we would use context to anything. Arnow478 asked some questions that I missed. Open source, GitHub, absolutely. Check out the GitHub link down below in the About section. You can see it's called Fun Compiler. It's in my GitHub. Here, I'll link it for you. It's in the chat. But yeah, it's absolutely open source, MIT license, so you can do whatever you want with it, as long as you don't blame me or use my name. And yeah, it's pretty dope. It's coming along, completely open source, pure C, no libraries. You can check it out. I recommend it. Arnow478 says, "Oh my god, you're OS dev as well. This is amazing. Lol." I do. I have made an OS. Negvorsa says, yes, open source in GitHub. Thank you, Negvorsa, for answering. Rohan says, time for the beloved debugger. Never. Nada. So good. I'm so glad Arnau is so excited. You know what, Arnau? You're excited? I'm excited. We're all excited. We're all so excited. So we can compile. We have mismatched types. We still get... Well, we're not getting our error anymore, so that's better. It's going to cause some issues eventually if the type that we're trying to return doesn't exist in the context where we're trying to call it from. So, no. Do we need some link between function definition and function context? Maybe. It's like we need to know which context function was defined within to properly check that return type is valid. Or get it at all, really. Okay. Yes, that's true. Arnell478 says, oh yeah, excitement. We are excited. All of us, this coding, it gets us excited. We like compilers, and that gets us excited. Oh, I'm so ridiculous. So we're doing better now. So now we have expression variable reassignment of a function called bar, and the right-hand side type is none. So now we're basically just going to say, copy our func return type into our result type, and maybe just use that in the first place. There we go, we did it. Chat. Chat, give us that pog bones, that pog champ. I need to see that T-Rex shining its shiny teeth at me, because we did it. We now get proper resolved function types. I mean, they're not perfect, but we are getting there. I'm gonna leave these in just for us. Alrighty, chat, we fixed it. Now when we go back to point, we should see that the code it generates I guess we just have to run it and see what it returns, right? It was gonna be 0. Succeeded with no output. That means it returns 0. We did it. Sorry there's gonna be a vacuum. It's gonna be loud. Rohan got that pog bones. RPWH got that pog bones. Thank you so much, everybody. I appreciate that so much. We got that pog bones. We're excited. We got this code done. It returns 0 like we thought it would when we tried it at first. Now this will return 69. Yeah, we did it. We did it. It's down here now. We did it. Whoa. Nexovex says, hey, is there any way I can compile your things assembly on Windows? Nexovex? Like this assembly? Yeah, I'm compiling on Windows right now. This is Windows. Everything's fine. It works on Windows, Linux, doesn't matter. You just need a C compiler. I'm pretty sure you could use GCC if you really wanted. See? And that probably generated a.out. What do we get? Yeah, a.exe. So yeah, you can just use GCC. Nexovex says, what is as? Arno478 says, is it WSL? No, guys, it's Windows. What do you want from me? This is Windows. Do I need to prove it? I'll say it 20 times for you. It's Windows. Jesus. Just Windows. That's all you need. You can do it Linux, Windows, doesn't matter. What is as? I'm sad. I'm sad that you don't know what GNU Assembler is. So GNU Assembler, Nexovex says activate Windows. Never. I never will. I'm not paying them a cent. Those bastards. Use the GNU Assembler. It's been around forever and it works. So I recommend the GNU Assembler. That's what as is, by the way. So you can see the GNU Assembler. You can also just use GCC. Just, you know what I mean? Which is the GNU compiler collection. So if you use the GNU compiler collection, I think you use on Windows, what is it? MinGW is what I have. Yeah, just use MinGW W64. This is a 64-bit GCC and LLVM runtime environment for C. So then you can just use a GCC that you get with this tool chain, and you just run it. Nexovex says, I'd like to use Clang. I don't know how to use Clang, but you can definitely do it. If you have Clang, all you have to do is feed it like it's a compiler. Look how you use GCC. The generated assembly, feed it to your compiler. I imagine it wouldn't be more complicated than Clang code.s, and it'll get what you're doing. You may have to say, hey, this is x86-64, but that's about it, right? Do I have Clang? I do have Clang. Let's try Clang. Do you know? I don't know how to use Clang. Clang.exe. Code.s. Does this work? It's only available in 64-bit mode. Well, can we enter 64-bit mode? Nexovec, tell me how to use it. Is that like a particular syntax? It's GNU syntax. How do you how do you use Clang? Assembly. Yeah, these are a bunch. Basically, do I do M64? Is that like where I'm at? It's not -M64. So if it's not M64, I have no idea how to use it this way. It's not different than any other way of using it. Just, I need to figure out how to use 64-bit instead of 32-bit. It's just passing Clang a file to compile. Treat it like a C file. It's exactly the same as a C file. It's amazing that nobody knows how to do this. This is like how I learned how to compile C and how it works. So it's amazing that other people don't have this fundamental down. Because you use GCC with -C, right? And then that will create an object file. But you can also use -S and it will generate these assembly files, which you can then... Ooh, Nexovet coming in with the help. --target equals x86-64. That's probably it. There we go. Shell command succeeded with no output. So now let's do dured. So now what do we got? Clang.exe. So now let's run clang.exe. What do you think is going to happen? Well, that's not going to work. We need to use the local one. Please. There it goes. Shell command failed with code 69. There's our executable. We can run file on it. See, it's a PE32 plus executable x86-64 for Windows. Nexovex says, what? I mean, it's just a compiler. It uses as in the background. Clang is just a higher level abstraction for you. For LLVM. But of course, it runs on everything. It's just GNU assembler syntax. This is universal at this point. It's been around for 50 years, my guy. It's not going anywhere. It works with everything. That's why we generate it. But yeah, this will work anywhere you want it to, my guy. As long as it's x86-64 machine, of course. But we're working on that. We're going to go to some not so platform-dependent output code eventually. But yeah, you were asking about our AST. That is absolutely our abstract syntax tree here. And it is a textual representation, which is printed out if you use the verbose flag to our compiler. So if you pass fun compiler, the -v or --verbose. Nexovex says, so like, where is some sample file? You mean the example file that I pass? No, I'll give you the pointer file that we've been playing with. You're on the Git, right? You're looking at the Git one? I don't know. This one isn't on Codeberg. I don't got to worry about it. So we're going to do new example with pointers. Pointers are fun. It's probably not going to work, so you're going to have to wait for this next one to roll in, just so you know. Because we changed a lot of stuff on how things work, and it's going to take a while for us to do this little get the committed, but we'll get there. I'm going to add in this little protection, because why not? So we don't parse, but we redid type checking entirely. So we're just going to do that. I'm not going to deal with handling it. So I'll do TypeChecker rework entirely. We were able to consolidate the two functions into one. Everything is much more understandable, readable, and concise now. Woohoo! Woohoo! Then we'll pushy that. Alright, it's been pushed. Everything should work. You should be able to do whatever you want now. And with CMake, you should be able to use Clang as well. This is also a comment. Oh, I forgot. We need to add that into our editor then. Comment starters. Yes, you. So comment starters and comment enders. I'd like to look at modify syntax entry. So yes. So 1 means char is the start of a 2-car comment. What does B mean? What does B, P, and N? It doesn't say. So B means char is part of comment sequence B. C means char is part of comment sequence C. N means char is part of a nestable comment sequence. Ooh. P means char is a prefix character for backward prefix chars. Such characters are treated as white space. Okay. So effectively, you can define like which types of comments. So you can have different comment sequences that start and end different. Yeah. So like in C, you can do, what is it? Where's C code? C code. Like in C, you can do // and it ends with a new line, or you can do /* and it ends with a next //, right? So they allow that different in the syntax entry. But yeah, we can add hash as a comment character. Set hash /pound. Sure. Can I load this file again? Wonderful. Can I go back to where I was and it fixed? Gotta reload unmode, revert file. I don't know. Can I go to like fundamental mode and then back to unmode? Nope. Still not right. We'll get there. It's probably has to do with the font lock. Comment base? No, we never set that up. So it's definitely the syntax table. Whatevs. We'll get there eventually. There we go, I did it. Chat, I did it. Syntax highlighting is now fixed. Can, I think, fix that. Do our little fix-up, Emacs major mode. So we're gonna do editor support, right? Emacs major mode now supports hash comment syntax. I think that looks good. And we are going to bushy this as well. It is now all live on GitHub. Beautiful. All these are comments. Yep, we can't use external calls yet because I haven't implemented those. Perfect. Very soon, we are going to have a working language. This is so cool. Very, very cool. Thank you everybody so much for watching. We have officially ran out of time. So currently, I'm going to point you to Rohan says perfect. Awesome. Hopefully it is perfect timing. Ooh, that was bright. Be sure to check out the fun compiler, start, fork it yourself, and make some changes, make a pull request. I don't care. We'll review you live on stream. It'll be fun. Negvorsa says thanks. Rohan says cat bag. Ooh, that's a Frank Face D. That's a cool emote. Cat bag. With the perfect. He spelled perfect with purr like a cat purr. Lamau. But yeah, check out the GitHub. Be sure to run the compiler yourself. Write your own programs. Figure out what you can do. Try and write a Fibonacci. Right? Do it all. Do it all. I recommend it. Along with the GitHub down below, there's links to the Discord, where if you are not already, you can get announcements every time I go live. Hey, is someone here? Hey, Arnow478. It's so good to see you. I'd love to have you here. Thanks for coming in. But yeah, we have announcements every time we go live. You'll never miss. Interesting. Accepting PRs? Of course. People can work on it. Don't don't do all the work. I still have to have a video series and stuff to do every day. Rohan says, I'll write you a Rickrolling code 5 error soon. Honestly, I would totally accept having, like, if you pass a special compiler flag to the compiler, it, like, opens a browser and Rickrolls you. Or it, like, downloads the Rickroll MP3 with curl or something. So you just end up with Rickroll.mp3, like, everywhere. You use the compiler if you end up sneaking this flag into someone's command line. That would be fun. I'm okay with stuff like that. We can have fun, as long as it's not malicious. Also, I missed 2 follows. Arnow478 and Segfit, both 20 minutes ago. Thank you so much for the follows. I very much appreciate it. We are that much closer to 100 amazing followers on Twitch. We're already above 250 on YouTube. You guys gotta... These are rookie numbers. Gotta get those numbers up. But yeah, there's announcements every time I go live on the Discord, and we have a ton of fun. We're all friends here. We share interesting code snippets and get help with what we need help with. All sorts of things. It's a lot of fun. Other than that, there is also the PayPal down below. I would greatly appreciate any and all donations that come in. I do not have any other source of income, so even if it's $1, it matters a lot to me. And if you leave a message and your name, I'll read it on stream. If you leave a message, I'll read it, but I won't say it came from you, obviously, because there's no way I could know. But I recommend doing that. And yeah, just thank you, everybody, so much. I feel like we had a great time today. We made great progress, and things are really looking up for us. So let us continue on this journey at another time. Thank you for coming with me for this coding session, this little coding session, and hopefully we can do another one sometime, because this was fun. Tune in. Usually it's like 8 a.m. PST. Currently it's noon, so like 3 hours ago is generally when I go live, wherever you are. Arnell says, coding moment. Yes. Yes. But yes, thank you everybody so much for watching. We are all done with the stream. Our compiler works. It type checks. It generates code that we can then compile and run with Clang, apparently. I didn't even know. But also with GCC and stuff. And you can just say, ooh, get that sweet, sweet 69 failure. Thank you everybody so much for watching. This is Beautiful Assembly. And I'll see you next time. Be sure to check out that YouTube, Discord. Click the links. Do the things. Love you guys. Bye-bye.